So we are giving that the present value is 9,000 and the periodic payments are $300 we meant, okay, and the number of payment is 40. So we have to find out this rate I per period by using this formula and our graphing calculator. So what we would do first is that we shall go ahead and uh, set up our equation. So in here, if you look at the formula that we have, we will write 9,000 for present value and 300 for the periodic payment. And n is how much? The n is 40, that's given to us, right? So we will write 40 here for n. And since we are using our graphing calculator and it takes x for the variable, we will just replace this I by what? X, okay? And see then what the solution for x is, okay? So let's go here. So we are solving these two equations. Which two equations are we solving? We have y1 and y2, and sorry, this one equation, I apologize. Okay, so we have to find the intersection of these two functions. Okay, I am so one function is given by this expression, and the other one is how much? 9,000. I mean, we can divide 9,000 by 300 and make the load a little lighter, but that's okay. Calculator is working, so let's take it slightly easy. Okay, so what we would do is this, that we will write it down as 300, then 1 minus 1 plus x to the power how much? Negative 40, right? And then we have division again by x, right? Okay, so we entered the expression here, and for the second one we are going to enter 9,000. Okay, so here we go. So we have the two values entered. Now notice this is 9,000, and we know that our rate is going to be between 0 and 1. So let's adjust the scales in a way that x min and x max are adjusted that way. And for y2, we have 9,000 here, and this is going to yield slightly a higher value. So it'll be a good idea to do this. First of all, as I said, that for the vertical axis, we may go for a value higher than 9,000, say let's go to 15,000 for example. So just for a good visibility of the x-axis, let's put negative 2,000 for the min here. Okay, so we have everything set here. So let's go ahead and graph the two functions and see what we find. Okay, so this is our first function, and then we should have our second function coming in, right? So it's right here, and we have to find the point of intersection of these two. Okay, so we can, I mean, let's just do this just for clarity. For y max, let's just put, no, sorry, for x max, let's just put 0.2 so that we have more space, because we can see right there that the rate that I is no more than 0.20. Okay, actually it's much less than that. So that way we would have, you know, a, a better space or larger space to click on the graph and the other stuff. Okay, so we want the point of intersections of a point of intersection of these two. There's only one here, so we go second, calc, we want the intersection, right? So this is my first curve, y1. This is my second curve. And for guess, let's let it guess as 0.1 because it is going to do the numerical calculations for us. So for the intersection, what it shows us that x is about 0.01 48462. Okay, so it's very small interest rate per period in this case. I mean, depends on uh, how long are we doing this for or how long the period is. So what we got here, x equals 0.01 48462. So here we go, point 0.014862. Let me see how my memory was working. 0.0148462. I forgot that 4 here. Okay, so 462. I could have kept both of them here together. Let me do that so that I don't have to do this. So 0.0148462. So very good. So this is the answer for X now, or the interest rate per period is how much? 1.5%.